had joined and they had left. So just 1 more minute, let's wait. Otherwise, then I'll start the class. Yes, class. I think we should start. Martin has also joined. So in the last class, we had completed that entire topic of thermal expansion and everything regarding it. So now straight away, let's start with specific heat capacity. All right. Now talking about specific heat capacity, one thing, thermal expansion of fluids also we have done. So that is a part of your syllabus. That was not something extra that we have done. So thermal expansion of fluids will also come. Okay. Now, specific heat capacity. What is meant by specific heat capacity? So see, before we describe anything else, just have a look at this. There's a block of mass M. Mass is M. Delta Q is the amount of heat provided to the body. Heat supplied heat is delta Q. Change in temperature will be T2 minus T1, delta T, because the temperature has risen from T1 to T2. All right. Now, what you have to remember is that the heat which is produced, this is directly proportional to the mass of this block. All right. This is proportional to mass of this block. Also, this heat is directly proportional to this temperature difference which is coming. Temperature difference, that is T2 minus T1. T1 was the initial temperature, T2 was the final temperature. So that difference. All right. So here when I'll combine, so delta Q is directly proportional to M delta T. A constant should come in here. So the constant that we put here, that is known as basically specific heat capacity, which is the topic of our today's class. This is specific heat capacity. Now see, if I want to define specific heat capacity, how can I define it? It will be delta Q divided by M delta T. Suppose I put mass, if I tell you, suppose I put mass as 1 kg and I put the change in time as 1 degree Celsius, what can I say about the specific heat capacity? Specific heat capacity is equal to the heat flow or the heat exchange or the change in heat or simply the heat required to raise the temperature by unit degree Celsius for unit kg mass. Now come to the main definition which is written. Specific heat capacity of a solid or liquid. Both are valid. Both have the same definition here. The way thermal expansion was a total different concept. Thermal expansion in solids was different. Thermal expansion in fluids was different. This is same. Specific heat capacity, solid, liquid, both are same. So specific heat capacity of a solid or liquid may be defined as the amount of heat required to raise the temperature of 1 kg solid or liquid through 1 degree Celsius. All right, specific heat is the amount of heat required to raise the temperature of 1 kg solid through 1 degree Celsius. Same thing. All right. And even if you want, you can find out its SI unit also. What is the SI unit of heat? SI unit of heat is joules per kg degree Celsius. Same, fine. And same thing you can write in CGS also. All right, calorie gram per, this is it will become Kelvin. All right. So this you can remember, CGS unit. Okay, one question. Let us see this through the help of one question. It will become easier for us to remember the formula. Formula is simple, MC delta T. That's it. MC delta T. C is the specific heat capacity. It's a constant, but it's not a universal constant. It varies with situation. It varies with objects. It varies with medium. All right, it varies with temperature. So it's not a universal constant, but it's the constant that comes in between. All right. Now calculate the heat required. So we want to find out what is the heat required to raise the temperature of 10 kg of water. Mass is given as 10 kg. Heat, what is the heat required to raise 10 kg of water from 10 degrees Celsius to 50 degrees Celsius? T1 is 10 degrees Celsius, T2 is 50 degrees Celsius. Yes, Alia, can you tell me what is the change in temperature? According to you, what should be the change in temperature?
40
Alia,
degrees Celsius. 40 degrees Celsius.
50 minus 10, that is
Yeah.
40. Okay, right. This is 50 minus 10, that is 40 degrees Celsius. Our formula is delta Q is equal to MC delta T. Everything is given for calculation of heat. Mass is 10 kg. This is 4.2 into 10 to the power 3. This is into 40. So I think this is either 1.68 or 1.08. This you have to cross check. 1.68 into 10 to the power 6 joules. This should be the answer. I have not calculated this right now. Whatever I means I remembered about this question, I have written. Please cross check once. I think it's this answer only. So anyways, I'm not focusing on the answer, the formula part. This is clear. Delta Q is equal to MC delta T. Very easy to use. We'll see molar heat's capacity and all also. First write this down. This heat capacity, then I'll discuss. Quickly write these down. These look lengthy, but these are very small points. It won't take time. Yes, class. Now, heat capacity, if the solid, the way we have taken the mass as 1 kg, if we are talking about 1 mole, molar concept, this you must have already studied in your chemistry's first lesson. So you must be familiar with the molar concept. So if it is about 1 mole, not 1 mole, number of moles we are referring to rather than mass. Instead of considering the mass, so same thing, the way we had Q is equal to mc delta T, we'll have nc delta T, where m was your mass, here n will be the number of moles. All right. So the way you had, and C is again, C is the molar specific heat capacity this time. C will be molar heat capacity. Concept and everything will remain same. Molar heat capacity. All right. So this will be equal to delta Q by N delta T. And again, joules per mole per Kelvin. This time take this as joules per mole per Kelvin. Take it like this. All right. I'll show you a question also. Wait. See, this question says calculate the heat required to raise temperature of H2 from 10 degrees Celsius to 60 degree and specific heat capacity is already given. So again, same thing, delta Q we have to find. Heat is Q. Always remember, heat is Q. So this is NC delta T. N number of moles that are given. See, calculate heat required to raise the temperature of, it's given 2 moles of H2. This you can add 2 moles of H2. So this is 2. C is 2.3 into 10 to the power 2. And delta T, 60 minus 10 is 50. So this will be 2.3 into 10 to the power 2 joules. All right. 2.3 into 10 to the power joules, this should come. So easy, simple based formula. Similarly, if the material that we are talking is water, 1 gram of water. So again, same concept here, the specific heat capacity will be specific heat of water whose value is fixed, which you should remember, that is 4200 joules per kg Kelvin. This you should remember. And one more thing, someone was asking, conversion. 1 calorie is 4.2 joules. Harsha was asking in the last class, she is absent today. 1 calorie is 4.2 joules. So this I have already told you, 1 calorie is 4.2. So here only specific heat of water is related. All right. So similarly, all the concepts are same over here. Heat capacity. What is the heat capacity? See, very easy. Delta Q is equal to mc delta T. M into C. M multiplied by C. This is written as S, which is heat capacity. Just the term heat capacity. Specific heat capacity, you use the term C. S is equal to, basically S is equal to M into C. So M into C will combine and it will become S. This is basically thermal heat capacity. Thermal heat capacity, delta Q is equal to S delta T. So formula will also be S delta T. So you should be aware, you should read the question well, which SI unit is mentioned. Because see, if you look at the SI unit, this time it would be just joules per Kelvin, right? Joules per Kelvin for S. The SI unit for S will be joules per Kelvin. Or in CGS, if we take, this will be calorie per degree Celsius. Correct? So you should be aware which formula is being referred. Like if this question is there, calculate the heat required to raise the temperature of a body from 10 degree to 110 and S is given. So I'll not search for the mass. Mass is not mentioned. Number of moles are not mentioned. So I'll not wait for it. I'll calculate delta T is 110 minus 10, which is 100 degree. Correct. And delta Q is equal to S delta T. So if S is given, delta T I can easily calculate the heat. It means this is asking in terms of heat capacity, not specific heat capacity or molar heat capacity. So this is 2000 into 100, which is 2 into 10 to the power 5 joules, like this. Alright, so all these are interlinked. See, we started with specific heat capacity, which is C. For 1 kg, 1 degree Celsius, then molar heat, instead of 1 kg, you have 1 mole. Then specific heat of water if the material is 1 gram of water. Then lastly, thermal heat capacity, which is the product of mass into specific heat capacity. Clear, class? Till where you all have written this question, no? Start writing from here. This is clear or not? Martin, clear?
Yes, ma'am.
Next is water equivalent. Now, water equivalent is basically, we had delta Q as MC delta T. I told you M into C is what? What have we studied? What was mass into specific heat capacity? Yes, Khadija. You must have written it in your notes. M into C. It's S. Thermal heat capacity. Please revise and come in the next class. M into C is S. Now, if mass is water and specific heat is of water, so this S, we call it as water equivalent. Same thing, all the things are same. I told you, all these things are related. So this is just specifically for water. So W is equal to M into C only. It's just that mass of water is there and specific heat capacity of water is there. So delta Q will be W into delta T. But what is the value of specific heat of water? This is very easy. 1 calorie per gram per degree Celsius. All right. So let's see question based on this. Calculate the heat required to raise the temperature of copper. This should be required to raise the temperature of copper from 10 degrees Celsius to 60 degree. Water equivalent is given. So again, delta Q will be equal to W into delta T. W is equal to 10 grams. So that's why I'm writing it into grams only. Delta T will be C. Delta T is 60 minus 10, that is 50 degrees Celsius. So since this is in CGS unit, this will be 50, that is 500 calorie only. 500 calorie only. Write this down. Water equivalent was left under specific heat capacity. Now you have latent specific heat capacity left. Latent heat is a different topic. This was all about specific heat capacity. Write it down first. Water equivalent.